right now. Good morning. You guys want to say good morning? We have a huge class today in here, but I'm recording this for you. So, all right. So this is Chapter 2, Section 6, Asymptotes, and okay, now I'm having a spelling issue. Was asymptotes 2 S's or 1 S? It is one. Okay, good. Because that'd be terrible if I had it spelled wrong on there. All right. What we're going to do is we're going to come in here, and this is going to help us with graphing. We're going to be able to figure out where we have vertical and horizontal and even slant asymptotes in a moment. But main things here, and for those of you at home, you may want to just pause it and write it down. We're going to quickly find vertical asymptotes. That is always where your denominator is going to equal 0. That is always where your vertical asymptotes are going to be. Horizontal asymptotes now, you always have to compare the degree of your numerator with that of the denominator. And those of you guys at home, I'm pausing you for a second so those in class can catch up. All right, so if you're going to have a horizontal asymptote, you're going to compare the degree of your numerator with that of your denominator. So there's going to be 3 parts, A, B, and C. So this is A. If your degree of your numerator is less than that of your denominator, then y equals 0 is your asymptote. Those of you at home, I encourage you pause that, write that down. But an example of that would be, let's say I have x squared minus 7, and then I need any degree of a polynomial down here bigger than that. So maybe I have 3x plus x to the 5th. So that because the degree down here is bigger than the degree, oh, you can't see where I'm pointing at home. The degree down here is bigger than the degree there, then there's going to just naturally be an asymptote at y equals 0. For you guys, does that part make sense? So you're just going to look at degrees. All right, then we're going to come down to the next one, and here it's saying the degree of the numerator is going to be the exact same as the degree of the denominator. Then we're going to have an asymptote at a ratio of leading coefficients of the numerators to the leading coefficients of the denominator. So an example here, bless you, would be something like if I have 2x squared minus 3x plus 8 over 5x squared minus 6, let's say. So my degrees, if I look at it, this is degree 2, and this is also degree 2. So my asymptote, I just take the 2 leading coefficients out, my asymptote will be at y equals 2/5. So this is going to be where that horizontal asymptote would be located on that one. Are you guys okay with that? As soon as we get going. All right, then the last option here is if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote at all. There could be something called a slant asymptote. And the slant asymptote is going to be if the numerator is 1 greater than the degree of the denominator, then we're going to have a slant asymptote, and I'm going to show you how to get that in a moment. So if it's 1 greater, you have a slant asymptote, still no horizontal asymptote though. And if it's any more than 1, then there just plain is no horizontal asymptote at all. No options. All right. So often we're going to have functions, oh, this is what I was talking about. Often we're going to have functions that will have slant asymptotes. They're going to happen when the degree of the numerator is exactly 1 bigger than that of the denominator. And in order to do that, you got to divide your numerator by your denominator, which is why we just did that whole unit on division. So if this is my problem, let me see if I can make that bigger. I can. So I have f of x equals x squared minus x over x plus 1. So what I immediately look to see, if I am going to attempt to graph this in any way, okay, right now we're talking asymptotes, so I'm going to finish that portion first. The degree of my denominator is 1. The degree of my numerator is 2. So that means this numerator is exactly 1 bigger than the denominator, so I can do a slant asymptote. So that means I need to take the numerator divided by denominator. You can do long division. Or in this case, because this is just a linear denominator, I can do synthetic. Connor hates synthetic, but the rest of you guys are okay with synthetic, right? Okay, so let's do synthetic. Connor, sorry. Deal with it. So we're going to have 1, -1, 0. And if I drop this down, I'm going to get 1, -1, -2, 2, and then remainder. So I do have a remainder. That's okay. So here's what happens when it comes to slant asymptote. We don't really care about remainder. All we care about is this leading portion here, the part that's okay. This would be the equation y equals x minus 2. That would be the equation of your slant asymptote. So I don't even need the remainder when I'm doing asymptotes. This is just what I get. So my slant asymptote, ASYMPT, will be at y equals x minus 2. So that's my slant asymptote. What about a vertical asymptote? Will I have one on this one? Yes, where? At -1. So horizontal, there is no horizontal asymptote at all because the degree of the numerator is bigger than the denominator. So horizontal, no. So there is no horizontal asymptote. That does not work. But vertical, that is going to be where the denominator hits 0. So that's going to be at x equals -1. That is where my denominator would go to 0. So if I actually had to graph this, those of you at home can't see this, but I have no battery in my microphone, so I am completely corded in. So if you hear a loud noise, everything's falling. All right, so if I were to graph this now, I know I'm going to have an asymptote at -1. I also have an asymptote at the slant one, so I'm going to do that in red. So starting at -2, and then I can go up 1 over 1, and I'm going to leave it dotted because it is an asymptote, but up 1 over 1. So there I have my asymptotes. My function is going to get close to those values, but never actually touch it. So what I would do from here, as long as I've got that, I'm going to plug in just a few random points because it will help me actually figure things out. So I go back to my very, very beginning function. And let's say I'm going to just make a XY table. I'm going to choose some values to the left of the vertical asymptote. So I'll put in like -2, maybe -3. And then I'll go to the right. So I will choose something like 0 and 1. I'm just going to pick a couple values because it'll just help me to know where things are going to be. So if I put -2 into the top function, I get 4 minus -2. That's going to give me a 6. If I put -3 in, I get 9 plus 3. That's 12. So -2, 6, 1, 2, 3, 4, 5, 6. That's up. And then it's getting even bigger here. So what I naturally know is going to end up happening, I wonder if it might come all the way down to the asymptote, or it might just come and do something like that. I am unsure exactly what it's going to do over there on the left. But here, if I put 0 in, I get 0 divided by 1, and that's just 0. So 0, 0. That now tells me that my values were up here on the left, but in the right, they're going to be inside this slant asymptote. So if I put in 1, oh wow, I get 0 again. Don't I? If I put 1 in to the very beginning equation, because it's 1 squared minus 1, which is 0 again. So that's just going to be 0. But that then tells me I'm going to end up with something that looks a little bit like this. And that's where the slant asymptote come into play. And it might very well do that here on the left. A lot of times it'll come on down and then it'll just do something like that. I didn't pick enough points to know exactly where it is. So what I would do you guys have the equation written? I'm going to switch to decimals quickly. Oh, sorry, I dropped you again. I'm going to come on over here to decimals. And it was, let me see here, it's x squared what? Minus x. Okay, so x squared minus x over x plus 1. All right. Oh, I have an error. Did you knew this before? Okay. the denominator. I did. All right, we're gonna come. Actually, I did on the -2 too. Just negative though. Yep, it's gonna go negative. I forgot my sign usage here. So if I put in the -2 up there, I forgot to do the denominator altogether. So -1 plus 1 is a -1. So that's going to give me a -6. Here, this was just my numerator. I still have to divide by -2, and that'll give me -6. So actually, that makes it a lot easier for me to graph, though, because I'd be down here at -6, -6. Wow, that would have gone a whole lot better if I'd caught that earlier. But good thing for us to see and check. I'm okay with that. But then it actually shows you better how those asymptotes come into play. I actually like that one better because it fit everything in there and we can get it to go. And then graphing on your calculator will make that come in a little bit easier for us too. Questions on that so far? Okay. So now what we're going to have to do in this section is we're going to have to do domain range asymptotes. We're going to have to do all those things. Actually, if I come back to this other one, as long as we started one, if I went in there and I already know where I have my asymptotes, I listed those. And now I have it graphed. If I have to do domain and range on this, let's go domain first. Is there anything that x is just plain never, ever, ever going to equal? There we go. I got a few answers, but -1 is the correct answer. So x just plain is never going to equal -1. That's my domain. D-O-M-A-I-N. That's an interesting D. There we go, domain. But range-wise now, there's going to be some gap in here. And right now, because I don't have it graphed really super well, to me, it looks like there's a pretty significant gap from here to here. I would be afraid to tell you my range right now. So I think I would go back over to the Desmos graph. And there is there's a gap in there. This appears to be my lowest point there. This appears to be my highest point here. So if I actually go and select those values, that's going to help me to get this here. Okay, go away. That point. And then pull that one away. That point. So if I were to go back to the other one, if I had to say range, I would say range y can be anything it wants except, we were doing interval notations, weren't we? Have we done that? So I could say ranges from -infinity up to -5.828 roughly, in union with, so I can get up to -5.28, but then I can't go anything above there until I get to the -0.172. So -0.172, and that can go all the way up to infinity. So there's how I actually would write my range on that one. If we weren't using a graphing calculator or Desmos, though, I don't know that we would ever know those values. There is not a quick, fast way to get them.